Okay, just to summarize on the sequences before we move on a little bit, what we're doing next is a little similar, but just to make some connections for you guys. Arithmetic sequences are what end up becoming linear functions, and that's why up here we got, and I mentioned that you want to get something that looks like y equals mx plus b, okay? So what ends up happening is that the value of your d is the slope of the line, because the slope of the line is what the pattern is. So linear functions are basically just arithmetic sequences that are graphed on a graph. Geometric sequences are the ones that make our exponential functions, and that's because they jump really, really high in value as we continue to multiply. So these are just two questions going along those lines. Find the slope of the line given by the sequence 4, 1, -2, ... We had a POD question recently that was similar to this. I don't think it was the same sequence, but so all we have to do is figure out what the common difference is, and it looks like each time we are subtracting 3. So the slope of this line would be -3. All right, on this one, find the base of the exponential curve given by the sequence. Well, the base number is the value of r, so it looks like we are multiplying by 2 each time, which means the r is 2. So the base number in our exponential curve, it would be based on 2 to the x. So that just kind of ties together why we're doing sequences. That's because arithmetic sequences are linear functions and geometric sequences are exponential functions. All right, we're going to go ahead and move to growth and decay to finish this sheet. So growth and decay, we're using only exponential functions. We have these two formulas that we looked at earlier in the year, and hopefully you recognize this. The y, or it's the function f of x, that's just the balance. That would be how much money you have left, or how much money your car is worth, or your house, whatever it is you're figuring out. And then the p is the initial amount, and it's actually called principal, but that's the amount that you're starting with. And then if it's a growth, we do 1 plus r. If it's a decay, we do 1 minus r. And that number in parentheses is the growth or decay factor, because that's what we multiply by each time. That's what factors are. The r, the actual letter r there, is the percent of increase or decrease. And then the t is in time. And the way we can tell if it's growth or decay, if the number in the parentheses is larger than 1, it's growth. And if the number in the parentheses is smaller than 1, it's decay. Okay, so our examples. Number 34. In 2000, the cost of tuition was $4,300. Over the next few years, the tuition rose 4% each year. That tells me that this is a growth. All right, so I know it's a growth, and I know that the r is 4%, which I'm going to write as 0.04. All right, so write the equation, actually I should say equation, that represents this story. So if we want to figure out the cost of tuition, then we're going to take the starting amount, which is $4,300, and then in parentheses, we're going to have 1 plus 0.04, which is going to be 1.04, and then to the x for the number of years. So that's the starting amount. The amount of increase or decrease was 0.04, so the number in parentheses is 1.04. And the growth factor is what we multiply by each time. So what was the tuition in 2016? All right, so what that means is that I want, if this was the year 2000, I'm going to think of that as being 0. And for this, since it's 2016, I need to fill in a 16. So I'm going to use my calculator to multiply 4,300 times 1.04 to the 16th. So grab your calculator, clear off the last stuff. So I'm going to do 1.04 to the 16th power. I'm going to go ahead and get that answer. and then multiply that by 4,300. And that tells me it looks like tuition is, in the year 2016, $8,053.82, to be specific. All right. Number 35. If y equals 200 times 0.8 to the x, is this growth or decay? And then name the rate of growth or decay. Well, first thing, I'm going to check inside the parentheses. The number that I'm going to keep multiplying by over and over and over and over again is 0.8. And since 0.8 is less than 1, that tells me that this is a decay. All right, so now it says the rate of decay. Well, if I'm multiplying by 0.8, that means that, let's see, I'll do it over here. That means that in the parentheses, 1 minus r equaled 0.8. So what would r have to be in order for my answer to be 0.8 if I subtract it from 1? So that would be 0.2, which means the rate is 20%. All right. Number 36. A 2010 Honda depreciates at a rate of 11% per year. The car was purchased for $25,000. So write the equation. Depreciate tells me that this is a decay, and the rate is 11%, which I would write as 0.11. So the value of the car, I'm going to call f of x. So it started out as $25,000. It's decaying 11% a year. So that means that the value each year isn't 100%. The value each year is 89% with x as the exponent. All right, the growth factor, really this should be the decay factor. So sorry about that, I just was cutting and pasting here. So the decay factor is 0.89, because that's what we're multiplying by over and over and over again. And look, see, I cut and pasted. So what is the tuition? This shouldn't be tuition, this should be the value. So what is the value in 2016? So I want to know in, oh, sorry, I almost messed up there too. All right, so here, hold on a second. 2010 is going to be year 0, which means that 2016 needs to be year 6. So I want to do 25,000.89 to the 6th power. So if you grab your calculator, I'm going to do 0.89 to the 6th power, get that answer, and then multiply that by 25,000. And it looks like the value of the car is about $12,424.53. That's pretty exact. So it's basically half of its value in 6 years. All right, 37. The population is modeled by this equation. So the population at a certain time is 6,191 times 1.04 to the t. Is this growth or decay? By what percent? And what is the 6191? All right, lots of questions here. Growth or decay? So I'm going to look at the number in the parentheses. Since it's larger than 1, I know that this is a growth. So this is a growth by, so now I'm going to look in here, and 1.04 is 0.04 away from 1, which tells me that my growth is 4%. So growth by 4%. And the 6191 is the initial population for this story. So that is the initial population. All right, that takes care of all of our sequences, and that completes the chart for 3B.